Okay, so this one. Now, this is what I mentioned in class before, on Monday before you left. So we go through the givens. It says AC is perpendicular to BD. That means the angles down at D for both triangles are right angles. So we got angle ADB. The right angle, the reason perpendicular lines form right angles. Yup. Okay, so that went through. We also got CDB is a right angle. Oops. Try that. Oh, yep. So that means that those two angles are congruent because all right angles are congruent. They're all 90 degrees. Now, also what that means is that those two triangles are right triangles. But let's see if we need that or not. If we have to do hypotenuse leg, we might have to say that they're right triangles. If we don't have to do hypotenuse leg, we can get away without doing that. Well, let's take a look. What else do we have here? BD bisects AC. So that right there, BD, the line going down, up and down, cuts AC in half. So that means AD, line segment AD, is congruent to CD because it was bisected. Segment bisector divides a segment into two congruent segments. No, okay, we got that. Now we also know that the two triangles there share that middle side. So BD is equal to itself, or DB, same thing. That is reflexive. So now, if we take a look, we got three things. We got a side, an angle, then a side. Neither of those sides are the hypotenuse. So I didn't really need to say that those two triangles were both right. I'm pretty much done at this point. Choose the triangle one, ABD and CBD. Those are congruent triangles because we have side, angle, side right in a row. And there we go. Now let's take a look here. We also got, let me see. This was the other one. All right. Now, for this one, we want to prove that ABC and CDA, the top triangle and the bottom triangle, are congruent. The only thing it gives us here is that the top and bottom are parallel and that the left and the right side are parallel. Well, before I even use that, we can see that CA there is shared by both of them. So we know CA is congruent to CA, reflexive. It's the same as itself. They share those sides. Now, like I said, when they tell you that we got some parallel lines, you want to start looking for like alternate interior, alternate exterior, corresponding, all those things. Now, if the top and bottom are parallel and we have that diagonal CA going through there, it cuts through those sides. So what that tells us is that we have some alternate interior angles. BCA is an alternate interior angle to DAC. So parallel lines cut by a transversal form, congruent alternate interior angles. Hey, there we go, and it marked them for us. In the orange there, they're in between the top and bottom parallel lines, and they're on alternating sides of that diagonal. Now that means also that BAC BCA they're also on opposing sides of the diagonal there. So now those are in blue. Now we have angle, side, angle, and we're done. So you go to the triangle, just like it says, ABC, CDA, and then that one is angle, side, angle. And done.